Now we will have a look at a very important concept in advanced automotive product development, which is modular platforms. Now the modular platforms are based on the concept of modularity, which is the practice of designing systems in the form of modules and attaching them together. Modular platforms are a cluster of systems which are bundled together and can be used for multiple vehicle products. As you can see over here in this example, so this is a platform. Now this platform will consist of many different types of systems. As you can see from this example, so this becomes the base module, or it is called as the platform. It includes the tires, the suspension, the powertrain, the steering systems, the supporting systems for the powertrain, the battery pack. In this case, this is an electric vehicle, so it will have battery pack, and it will be having the frame which houses the batteries, and the subframes which is having the powertrain as well as the suspension system. So this becomes the base platform of the vehicle. Now this can be adopted to many different types of vehicles. As you can see, it is adopted to this vehicle, and the other two vehicles are also having the same platform. The only difference over here is the body and the cabin. The cabin will be different, but the base, the foundation of the vehicle, which is this module right here, will remain the same for all the three. This of course is a very advanced design methodology which is used commonly in OEMs today. Now this requires that you design systems in such a way that you are adapting them to multiple different types of vehicles. So in one way the design has to be rigid, in the other way design also has to be flexible to adopt different types of vehicles. Now to do this, it's very difficult, and hence a lot of effort is put into the design phase, in which these kind of systems, these modular systems can be developed, which can be flexible and adaptable to many different types of vehicles. You can see these platform sharing concepts in most established OEMs today, whether they are Volkswagen, Renault, Nissan, Mercedes, BMW, Ford, etc. The philosophy over here is to standardize as many parts as we can across vehicles to reduce repetitive product development effort. If we are reducing the number of new parts which are being developed in product development, we will reduce of course the cost and time of product development. So that is the idea behind this platform sharing concept, and it is highly effective. Now as you can see over here, there are different types of vehicles to which this platform has been adopted. So this is kind of a sports car, this is a SUV, this is also an SUV. Now these three vehicles will not have the same vehicle specifications. They will have varying wheelbase, they will have varying width, they will have varying length. So all of these variations have to be adopted into the platform design. For that, some elements are made flexible and others are made fixed. The modularity concept of having various types of modules which can be mixed and matched with each other to get different types of products is a very important and powerful philosophy which is applied in this kind of design. Now we will have a look at the key characteristics of a platform. So the platform forms the foundational structure of the vehicle, including the front, rear and the underbody. Now this is applicable to both body on frame and monocoque type of vehicles. The monocoque vehicles generally would include portions of the body or BIW as well, along with the base structure of the vehicle. We will be able to understand this with examples in the coming slides. Another key characteristic is that the platform will always include the front and rear axles. They will be always included in the platforms. The steering mechanism and the technology of power steering will also be included, as well as the front and rear suspensions. So front and rear suspensions are an integral part of the platform, along with the subframes which are going along with them. So the suspensions are mounted on the subframes. Those subframes will be included in the platform. Then the powertrain package. The powertrain package, the orientation, the variability of the subtypes of powertrains are also designed for in the platform. So for example, if you are having a variety of powertrains, which is normally the case in today's vehicles, which are having like 5 to 6 varieties, then all of these variations of these powertrains are designed for in the subframes for the platform. Platform sharing is a product development strategy. So planning for it is done in the very initial stages of product development. So before the business case has been prepared, the platform sharing strategy has to be in place. Now, this is generally applicable for new product introduction type of projects. So when we are developing new types of products for the market and introducing them into the market, that is when these platform sharing techniques are the most useful. This can lead to either simultaneous development of multiple products on the same platform. This can happen, or it can be a staggered development in which one product is first developed and then later the second product is developed and then even later the third product is developed. So there can be staggered or simultaneous product development which is happening for multiple products. So when we are adapting platforms to various types of vehicles, we are talking about vehicles which are in different categories as well, means sedans, hatchbacks, even SUVs. So in that case, the requirements of the individual vehicles can be different. How do we cater to those varying requirements by having a single platform? That is a very key design challenge. These challenges are generally met by providing flexibility in the design. For example, the flexibility is provided in terms of the wheelbase, the front and rear overhangs, the wheel track of the vehicle, the overall width of the vehicle, and some other vehicle specifications. So all of these are kept open and which can be tweaked and varied for various types of vehicles. Of course, this kind of a design which is flexible and also standardizes a lot of parts of the platform requires a lot of thought process in the initial stages of the concept development. So the performance attributes like peak power, torque, and other attributes may differ between the vehicles, but most of the basic features, the foundational features, and the static and dynamic behavior of the base structure remains similar. So because of the varying body types, because of the varying weights, and because of these varying vehicle specifications, there will be differences in the performance attributes of the vehicles, and also there will be differences in the targets which are set for the performance. Platform sharing is done between vehicles of different types, but the variation of the type of vehicle will not be very great. For example, we will not have a platform sharing strategy between an off-roader and a hatchback. That is a very difficult strategy to meet because the requirements of an off-roader might be very different than the requirements of a hatchback, of an entry-level hatchback. So we can have a platform, a common platform between entry-level hatchbacks and entry-level sedans, but we cannot have a common platform between a heavy-duty SUV and an entry-level hatchback or a sedan. That is because the type of loading pattern, the type of usage pattern will change drastically between the two. Now we will have a look at some examples of platforms which are used today. So this is the Volkswagen MQB platform, which uses a transverse engine front wheel drive architecture. So this architecture is shared amongst many Volkswagen Group models. As you can see over here, Volkswagen Polo, Tiguan, Seat and Audi A1, all of these vehicles probably share this type of a platform. So here we can see in detail how exactly the platform would look like and what kind of parts would it include. So we can see that the engine and the transmission, which is the transaxle, is shown over here, and all of the supporting components which go along with it, the supporting systems like the cooling system over here, there is a radiator, and then there is the whole engine bay which is included over here, which is a part of the BIW, and also there is the subframe which will mount the suspension as well as the powertrain. So the suspension system over here, shown over here, is the McPherson strut that is in the front, and in the rear it will be the twist beam suspension system, or it can be the multi-link suspension system as well. So this is housed in these structures. So this is the front end structure, this is the underbody on which the seats are sitting, and then the rear end structure. The wheelbase will be flexible in this case. So these elements, this structural element will be having 2 to 3 variants for the various vehicles depending on the wheelbase, and based on that it will be attached to the other components of the module and to get the different types of vehicles. And similarly, there will be some systems and some components which will have 2 to 3 varieties depending on the vehicles. So it is not exactly the same parts will be used in all the vehicles. There will be some variations in the parts, but those variations will not be major. Most of it will be standardized. Looking at this, we can appreciate the cleverness which has been used in the design and how one type of design can be applicable to many different types of vehicle models with maximum standardization. Now let's have a look at another Volkswagen Group platform, which is the MLB platform. Now this MLB platform is a shared modular construction for longitudinal front engine automobiles. So automobiles which are having the front engine but are longitudinally placed as shown over here. So we have seen earlier what is the difference between longitudinal engine placement and transverse engine placement. So this platform is mostly suitable for longitudinal engine placement. Vehicles like Audi A4, Audi Q5, Audi A6, A7, they have this MLB platform integrated along with them. So all of these vehicles uses the core matrix of the MLB components across a variety of products. So the MLB can be adopted to a variety of powertrain mountings. So if there are different types of powertrains and they have different types of mountings, then that flexibility is inbuilt into the platform. There is a flexibility of body style, powertrain size, which is inbuilt into the platform, which allows it to be used for many different types of vehicles with maximum number of standardization. The two platforms which we have seen are for the monocoque or unibody type of vehicles. Now for body on frame or full frame based vehicles, it becomes much more easier. So this chassis with all the subsystems and systems mounted on it becomes the drive-away chassis, which in itself becomes the platform. So this drive-away chassis becomes the foundation or base of the vehicle on which different types of body styles can be accommodated. For example, you can change the wheelbase of this frame by just changing the middle member of the frame. If you are having 2 to 3 variants of wheelbases of vehicles, if by changing the middle member, you can accommodate them into the same design with very less changes in the manufacturing and the product development effort. As we have already seen, full frame based type of vehicles are generally ones which are large SUVs and pickup trucks. So these manufacturers of these large SUVs and pickup trucks very widely use this platform sharing method, because it's much easier to have a single type of a frame manufacturing setup and use it for multiple products than to have different assembly lines for each and every product.